Computers are probably one of the most important human inventions. It allows us to communicate and calculate faster than humans could ever have. These calculations are done on processing units, microchips, mainly made of silicon, and have been getting smaller and smaller. Moore's law states that every 2 years or so, the number of transistors on an integrated circuit chip will double. Couple this with the extreme die size shrinkage since the inception of these circuits, and it is quite safe to say that we are reaching the physical limits of the traditional computers soon. As the transistors are becoming just a few atoms in size, any smaller than this, then the electrons start to jump around and the calculations become impossible due to the level of noise. Enter quantum computer, a new type of computer that may revolutionize the entire computing world. What is quantum computer? Quantum computing is a tough subject with in-depth physical and mathematical knowledge being required to fully comprehend its function. So to begin, let's take a look at how our Prime Minister has to say about it.
I was going to ask you to explain quantum computing, but when do you expect Canada's ISIL mission to begin again? And are we not doing anything in the interim while we prepare?
Okay. Very simply, normal computers work by... Don't interrupt me. When you walk out of here, you will know more. Well, no, some of you will know far less about quantum computing, but most of you, normal computers work either there's power going through a wire or not. It's 1 or a 0. They're binary systems. What quantum states allow for is much more complex information to be encoded into a single bit. A regular computer bit is either a 1 or a 0, on or off. A quantum state can be much more complex than that because, as we know, things can be both particle and wave at the same times, and the uncertainty around quantum states allows us to encode more information into a much smaller computer. So that's what's exciting about quantum computing, and that's what we're
To reinforce what he said, quantum computer is a type of computer that uses quantum mechanics and its phenomena such as entanglement and superposition to complete calculations. It is currently mostly theoretical, but the research around it is getting more and more advanced. Its unique operations will allow it to perform certain tasks exceptionally faster than traditional computers and poses to be a real paradigm shift in the quantum computing space.
In a traditional computer, bits are the smallest representation of a data, with two states, 0 and 1. Each bit can either be one of 0 or 1, and its position within memory is definitive. In a quantum computer, things, however, work a little differently. They instead utilize qubits as the basic representation of data. Though they are still zeros and ones, they also can be both at the same time. Using spins and the magnetic field produced by something like a photon, and the quantum mechanical phenomenons of superpositioning, the qubit can be any proportion between two values due to its polarization. But as soon as the calculations are finished and the photon is observed, it needs to collapse into either 0 or 1. This means that only thing you have is a bunch of probabilities for zeros and ones until its measurement. Traditional computers can only store information in one definitive state, so even with 5 bits, though there can be 32 possible scenarios, it can only store one value. On the other hand, quantum computers can store all 32 possible values simultaneously, and its capacity only increases exponentially as the number of qubits increases. Traditional computers are made up of transistors at the smallest level. These transistors come together to make logic gates, performing logical operations such as AND, NAND, OR, etc. These logic gates come together to make different sections of the processor doing very simple things like addition, subtraction, and multiplication. Coupled with some other modules like for floating point, which is a computer's way of representing decimal, a computer can basically perform any mathematical operation. Quantum computers also manipulate data with gates, and these gates are called quantum gates. Their function is slightly different though. Instead of putting definitive outputs from a definitive input, it rather just intakes few superpositions and outputs it as a new superposition. At the end of calculations, using quantum gates, one can collapse the set of superposition and by the means of clever quantum bit manipulation, obtain multiple possible solutions for an instruction. This is a massive time saver compared to a traditional computer, as it means that calculations are done in parallel and does not require extra processing cycle and time to complete the same operations.
The main advantage of quantum computers are its ability to process information in parallel and therefore save time on massive calculations. There are many applications in real life where this may be tremendously useful, and a few examples of them are prime number factorization, database searching, and simulation. Prime number factorization utilizes complex algorithms to find out the factors for a very large odd prime number. Traditionally, you would have to test out tons of values to find a factor, and a lot of the time it can take anywhere from a few days to millions of computing time. Quantum computers changes that. Through quantum application of Shor's algorithm, one can find the factor in polynomial time instead of exponential time, which means huge time savings for the calculation. When finding something in a database, one utilizes many clever algorithms to find the data in need as quickly as possible. Unfortunately, in a database that is filled with millions upon millions of entries, that would still take a very long time. For quantum algorithms, it only requires square root of the traditionally required time. This is massive and will bring huge improvements to services and research that traditionally require large data entries. Simulations of small molecules in actual quantum physics are often very costly computationally and still lack the mathematical accuracy that many would like to enjoy. Computer folding and other distributed computational methods are commonly used for these types of calculations, but they are not the best. Through simulation of quantum physics with quantum physics itself, by speeding up the calculations immensely, research in these fields can be vastly sped up and will lead to more discoveries in molecular and quantum level. Quantum computing is something we had never even imagined before, and therefore it brings limitless possibilities, many of which we have yet to discover. But here are some of the very significant impacts of quantum computing that we know of today. Traditional means of encryptions will be broken very easily. Today, important information is being shared across the internet, and stored on devices are encrypted through keys. These keys are private, and though the public version of these keys exists for senders to encode message with, they are very unlikely to calculate the private keys due to it being a factor of a large odd prime number. Well, with the quantum computer and the aforementioned applications of it, it won't be very hard to find these private keys, and the vast majority of our encryption system that relies on it, excluding the elliptical curve encryption, will be useless, leaving banking information, classified documents, and private data for anyone to view. Quantum computers can serve to improve research quality and progress in mathematics, physics, and biology, among other fields. The ability to process massive amounts of data, as well as the more accurately simulate the events on quantum and molecular levels, cures for diseases, new physical phenomenons, and mathematical theorems can be discovered and proven, and therefore has limitless potential to help humanity.